So in this video we are going to look at how the settings in CLO impact the ability to set up a similar drape in carbon. And we're going to look at three aspects. We're going to look at the simulation properties, the material properties, and collision. So here's the standard avatar and the standard t-shirt, and I've removed the collar because it's easier to visualize the collision without the collar. We've got the standard default simulation setting, and we've got the default fabric. So if we run a simulation, we get a certain drape, and that looks fairly good, and that's because the default fabric and the default simulation settings are designed to make a drape look nice and smooth. But in reality, we almost certainly want to replicate an actual fabric. So we've got here a knit cotton jersey, so let's apply that to our garment. Okay, so now we've got a real fabric. Rather than running a normal simulation, which is the default, we want to run a fit simulation, because that will actually give you an accurate fabric property. And then the final thing, we need to run with more resolution, because this is a 2 centimeter particle distance, and for any sort of smooth result, that's way too big. So we need to run, I would say, less than a centimeter. There. Okay, so now we can simulate this with accurate fabric fit simulation, and you can see immediately a difference in behavior. The drape is much higher than it was with the default settings. This wants to run for a little while, so I'll jump ahead, but nothing changes. It just won't stop simulating for a little while. There we go. Okay. And now if we look at the back, we can see much more creasing than we had before, because this is applied to real fabric properties, and with those fabric properties, this garment panel here is too big. As you can see, it's folding up at the shoulders here. It needs to be smaller, but it's very good for demo purposes. Now, when you bring this into carbon and you run a carbon simulation with a knit cotton jersey material property, you get something very, very similar, as we'll see in a little while, to this. But there's one more aspect we need to consider, which is collision. The default settings give you a large gap between the avatar and the garment. So the defaults in CLO are 3 millimeters of what they call skin offset, and then the garment itself has an additional 2.5 millimeters of offset, called additional thickness. The fabric itself, just less than a millimeter, it's 0.78 millimeters. So we've got 3 millimeters offset, and then we've got half of 2.5 millimeters, so we've got 4.25 millimeters to get to the edge of the cloth, and then we've got a thickness of 0.78 of a millimeter through the cloth. You can make this smaller, and depending on your simulation, something like this simple t-shirt will simulate no problem with pretty much no skin offset and no additional thickness. But complex garments, and particularly multi-layer garments in CLO, you may struggle, and so you may need to replicate this offset in carbon, and we'll look at how to do that in a minute. So that's really what I wanted to show you here, and there are other videos that show you how to export these garments from CLO into carbon, but I'm going to jump into carbon now and talk about how we deal with some of these aspects once we get into carbon. In this video, we're going to look at several aspects of bringing a garment from CLO into carbon in Maya or Houdini. We're going to look at setting up collision distances, simulation properties, and material properties. So here we've set up the garment using the garment processor, and you can look at a separate video that explains how to do that. So first, let's look at material properties. This garment was simulated in CLO using the knit jersey material, and also using the fitting simulation. In carbon, as part of the garment processor setup. It takes the original start mesh, which we exported as a triangle mesh, and it turns it into a quad meshed garment with very, very specific conditions, matching the armpits, for example, with the body. And although this mainly looks like a pure quad mesh, from a simulation perspective, there are also cross properties as well. And the reason we need this setup is because only with a quad mesh can we accurately replicate weft, warp and bias. Triangle mesh is a bit too random for accurately representing fabric properties. So we've got this quad mesh. To that we're going to apply a similar material to what we used in CLO. So if we go to our material, we can load a material file, and I'm using this jersey knit file, and that's, when we reset the simulation, automatically applying the material properties to all our cloths. Now here I'm actually using a stitched garment, and one of the advantages of a stitched garment is that I could actually apply different materials to different parts of the garment. So if I was to go here into the cloth, I could use material and put some specific parameters here, for example, or I could put another material into the scene and change the material that this particular panel is using. So that's one of the advantages of using separate panels. Another advantage is that it simulates quicker, because it's simulating panels that don't connect at the same time. That sets us up with the material. Now, in the material itself, it tells you approximately the settings needed for the simulation in order to get a representative material. And so if you've got up to 20,000 triangles, it suggests values of 10 iterations and 100 subdivisions, and 20 to 120,000, 10 iterations and 200 subdivisions. Now here we have about 31,000 triangles, and so 200 is probably too excessive because it's not that much more than 20,000. I think I would start with 10 and 100, and let's just see how that behavior is. So to do that, we go into the carbon simulation and we set iterations at 10 and subdivisions at 100. Now these are probably higher settings than you normally would use, but if you want to get a good weft warp bias behavior, then you need convergence of the simulation, and to do that you need a reasonable amount of simulation. And if you've got a fairly fast machine with 24, 32, 64 cores, then this will still run pretty quick. While we're here, we also need to set the length scale, because our character's in centimeters, into centimeters. It defaults to meters, but we're going to set to centimeters, and that's the simulation settings done. Other thing we need to do is to set the cloth thickness. Our cloth thickness from CLO for this material is 0.78 millimeters, so that's 0.078 centimeters. Now we need to hit reset for it to actually feed these parameters through. We can do it all in one go at the end, but I like to do it as I go along. So that's the material properties setup and the simulation settings. The last thing we need to look at is the collision settings. First thing we need to do is actually to create a collision object for the avatar body. So I do that by selecting the body and then going up to the collider here. With the default settings, we can see that we've still got a massive gap between the start mesh and the body. And if you remember from CLO, that's because by default CLO has a 3mm skin offset and 1.25mm either side of the cloth. So that's a 4.25mm collision gap between the edge of the cloth and the body. So we can replicate that in carbon by going here to the collider, making it single-sided. We'll make the internal collision 1mm. The internal collision is limited to half the distance of the narrowest part of the collider. The outer collision, which we call fatness, already said we need to make it 4.25. So that is replicating essentially the conditions in CLO. The difference here in carbon is we're going to actually expand the size of the avatar by doing this. Okay, so now you can see we've expanded the avatar. There's no gap now between the garment and the avatar. Because we're running under similar simulation conditions, when we run the simulation now, we are not really expecting this to change very much. So let's just run 12 frames. And as you can see, there's very little change, as we'd expect, because the simulation conditions are pretty similar. There's a little bit more change on the back. We haven't got perfectly exact material settings and simulation settings to CLO, but that's pretty close. Now you'll notice here, as we mentioned in CLO, this garment is too big. The panels are not suitably sized for accurate fitting. That's got nothing to do with the CLO sim or the carbon sim. It's simply the cut of the simple t-shirt we chose. Now, an under the hood feature that makes all this work is the fact that we take the start panels and extract from them the original flat panel sizes, and then we use those as reference panels in carbon. If we were to look at an individual cloth here, we would see that basically we have a start mesh and a reference mesh, and that reference mesh has been generated from the start meshes. It's the original flat panel patterned shape and size of the garment, and that's used as a reference to apply the material properties to get the right simulation fit. Hence we're getting the same result in carbon as in CLO. If we didn't use a reference, then it would stretch, because we were essentially draped under gravity to begin with, and now we would be redraping under gravity an already draped garment. But because we're using reference panels, from a simulation perspective, the garment wasn't draped. And so we drape again and we get pretty much the same result. So this was an example from CLO where we used the fitting simulation and a material property. If we had simply exported the default fabrics and default simulation settings, we would have got rather a different result. And as you may actually be given that output, let me show you how to deal with that. So this scene has a start mesh from CLO where we used the standard default fabric and the standard default simulation. And you'll see that the simulation result from CLO that we see here is rather different to the one that we get from the fitting simulation and the jersey knit material in CLO. So those are the two different starting points. Now, as we saw in the previous video, when we simulate this one with the carbon settings, we get pretty much the same result as the start mesh because we're using very, very similar simulation settings. If we go and look at the import from CLO when we use the default material and simulation settings, then we get rather a different result when we apply carbon, because of course the simulation settings in carbon, that's much more like the fitted simulation from CLO. So that's the fitted simulation from CLO. As we saw, the result of adding the material properties in carbon gives you a very similar result between fitted in CLO and unfitted simulation in CLO. But if you want an even more exact result, then you actually need to turn off friction on the avatar in carbon, because the start mesh for the unfitted version of the simulation from CLO is slightly longer. That is impacted by the friction on the body. So here we have an example where I've removed friction here from the actual avatar. So that's the result with the default simulation and default material in CLO. And then if we compare that with the fitted example from CLO, but with the carbon materials applied, you can see that they're very, very close. So if you have not used a fitting simulation in CLO and you're happy to apply that in carbon and get the fitted result, that's fine. If, however, you wish to maintain pretty much this look that you got in CLO with the default simulation, then you need to remove the use of reference panels in carbon. And you can do that by going to the material, and you see down here we have the option to blend the reference between the start and the reference mesh. And if you set blended reference and set the reference to 0, which is 100% start mesh, then if we reset the sim, you'll see we get pretty much the same result as the output from CLO. It still stretches a tiny bit under gravity, and we can even remove that if you want by going down into the carbon material and just reducing the stretch extension from 1 to something a tiny bit smaller, so maybe 0.995, just 0.5% smaller. And if we reset the sim, rerun, and I'll just jump ahead. Yeah. And you can tweak that to get the stretch you want. So that's one way you can maintain the same look as you got from CLO with the standard default simulation and default material. And you can use a combination of these techniques to basically achieve the look you want. So I hope you found that useful, and thank you for watching.